good morning, good afternoon, everyone from different parts of the world. Welcome everybody to this ACDC Summit, Direct Current, Your Next Energy. My name is Vivian Montoya. I am the Smart Power Division Global Communications Manager, and I will be with you to bring you through a journey on direct current world. Welcome to the second day of our journey across DC solutions involving experts, professionals, and gurus able to inform and update you about DC evolution. Our aim is to create a network that starts today and will continue being interactive for the upcoming weeks and months. ACDC Summit will remain as a live platform to interact, discuss, get in contact with our experts, propose new topics, and find out more and more contents. Many live sessions touching different topics and going in depth of a specific argument that you want to know. To make the most of this summit, we strongly feel the need to give you place for interactions and the option to discuss some trends. Also, we would like to receive all your questions, and to do that, in any session we will have a live space created to discuss, comment, and for sure to answer to your questions or doubts. We also would like to collect your feedbacks about the event and other topics for applications that you would like that we go deeper. Therefore, we will be using a very easy platform called Slido. Slido allows you to submit your questions as well as upvote the questions of other participants that you find interesting. You will also be able to interact with us through online polls. We will have a red button in the live sessions where you can place all your questions and you can interact with our experts. Let's start with this exciting day.
Hello, my name is Arno Bronswijk. I'm working for ABB at the R&D department in the Netherlands. For the past 7 years I was following the Active DC development in the Netherlands and also participated in the Dutch standardization group for making this Active DC technology a general standard for industry. This is still in progress. First I need to explain what the difference is between a traditional DC system and an active DC system. A traditional DC system is using passive reactive components which react on a faulty situation. So when the current rises, for example by a short circuit, it rises to a certain level and that will generate enough energy to trigger a mechanism to break the circuit. By managing the system with electronics, it is possible to handle these capricious properties of the sustainable sources in a more efficient way. With the support of the Dutch government and a couple of companies, a new unique system was developed. It's called Active DC system. A unique property of an Active DC system is that it is fully controlled with electronics and it doesn't need any external data. So reacting on the voltage level in the system, it will be able to detect when the voltage is rising. That means that there's an abundance of energy, and when the voltage is dropping, there's a shortage of energy. And with these facts, it can react automatically on this situation. The way the system should respond is embedded in a protocol, and that's called current OS. The protection of the system, that's done with solid state technology. This solid state technology is electronically and is very fast. And by making use of this speed of these electronic components, it is possible to operate on a higher voltage level in order to reduce the losses. A higher voltage level means lower currents, and lower currents means lesser losses, and that results in a higher system efficiency. Because the system is designed in such a way that when a faulty situation occurs, it switches off before the current can rise to a dangerous and unmanageable height. Today we are going to visit some locations in the Netherlands where Active DC is applied, and I hope this will trigger your interest to know more about this system. So go with me on this journey through the Netherlands and see what projects has been done.
Pulse is a new education building on the TU Delft campus, between the faculties of Industrial Design and Engineering. Pulse is the first energy-neutral building on campus. The building has an A+4 energy label. The roof is home to 490 solar panels, 750 square meters, with an annual yield of 150,000 kilowatt-hours. The solar panels provide sufficient energy to power the building. The building is also equipped with underground thermal storage and super insulating glass. An intelligent building management system ventilates, lights, cools and heats the various spaces at Pulse in line with their use. The facade openings were designed to make optimum use of daylight, thereby decreasing demand for electric lighting and, as a result, power. The panel's direct current output is used throughout the building for lighting and USB-C connectors.
My name is Wim Verhaalte. I'm working by the TU Delft, CRA Campus Real Estate, Department Maintenance and Engineering. And I'm a maintenance engineer, and I'm responsible for the installations that they compare with our maintenance program. So, as you know, it's a technological university, and yeah, we have to follow the technical developments. Yeah, I think DC networks will be in the near future very important for us. It is easier to couple with other systems, and I think it has more benefits than AC. With the design of the installation, we have the problem there are no standard products for DC, and that is one of the reasons that we only using the illumination installation for it. Well, I think for DC installations it's important that we have regulation and products. That are the most important things at this moment. When there is a regulation, you may use it, and when you can use it, they're coming up with products. This is not only for DC, but it's also for smart building technology. We can design on paper very beautiful systems, but when they're not products enough, you can build it. So, and producers like ABB have to build or design products and make them usable for us, then we can build a system.
The Circle Pavilion is built entirely based on circular principles using recycled and reusable materials. It's a living lab where experimental and innovative solutions meet the challenges of the future. They want to persuade society to move towards a sustainable world by demonstrating the changes needed to create the circular economy, both in theory and in practice. By using the very latest technology, the Circle Pavilion is completely energy neutral. Thanks to the smart direct current system for distributing electrical energy, the efficiency of the system was increased and thus the required capacity of the grid connection reduced. The ABN AMRO hopes that everyone will use the new knowledge and experience they have gained through the circular construction of this building. That's why they don't refer to what we've done at Circle as copyright, but rather as right to copy. What you need to learn to do, you learn by doing. Dreaming, daring, doing and sharing.
My name is Rob Vermeij. I'm category manager buildings, and I'm responsible for the maintenance and new products inside of the ABN AMRO Bank. And I'm also responsible for the sustainability and the long-term strategy for that. Yes, DC is a product we saw it by our startups. Interested for us because the building where we are is a living lab, and we try out all new products and also the DC, and it was important for us because we think it's important for our future for the energy transition. Yes, we have two benefits. We have a strategic plan for circularity, and we have a strategic plan for the energy transition. And for both strategies, we need this experiment. The adapters, you don't need them in the future. And for the energy transition, our energy level and usage will come lower. I think it's important you have local grids. So you have your building and your energy neutrality in the buildings, which is solar powers. You need a local grid in case of the central grids on this moment with the power supply in the big energy stations. You have a lot of electric installations you need for all the buildings, and if you can make this smart for that specific building, that's the future, I think. I think it's also a mindset for our electric engineers in the Netherlands. They don't have the experience with DC in our buildings, but if you take a look to our cars, electric car, by shipping, it's all DC. So it's new for the buildings, but not new for the cars. A mind change, so that all the electric engineering for buildings get the experience with direct current. And it makes a lot of easier if you see in the future when you have made the change, you can also grow to smart buildings, to connections with the internet. And so there are a lot of opportunities in the future when you started by direct current.
Public lighting ensures that we can move comfortably and safely during nighttime. However, the way we use public lighting also has negative energetic and environmental aspects, which are becoming more and more important. When you fly over our urban areas during the night, you realize what a huge impact this has. By using smart DC systems, it is possible to reduce the amount of raw materials up to 80%, reducing energy consumption and extend the life expectancy of components. The properties of the smart DC energy distribution will also enable the possibility to use the infrastructure for other purposes during daytime, which is very difficult to do with the traditional AC solutions. So using smart DC systems not only increases the system efficiency, but it will also offer more functionality.
My name is Wilfred Akerboom. I work with CityTech. CityTech provides public lighting in the Netherlands, and this is a system integrator for outdoor systems. And my daily work is I'm a product manager, and since 2013 I'm occupied with direct current projects, and we have done a lot of them in the Netherlands already. It's a new system, so at the first you always have to face some challenges, but we meet them. So now it's working fine and reliable. Here at the Business Park Nieuw Rijewaard, they choose for public lighting on DC because they want to have sustainable, future-proof installation. The company that gives us the assignment, it was energy company. They want to accelerate the energy transition for the coal to be carbon neutral. And we have here a DC grid for public lighting, but we also have a backbone. And with that backbone, in the near future, we want to couple energy storage and local energy production, so by wind or by solar, so it can be completely self-sufficient. We can use also DC for smart grid applications. So now a lot of our customers want to make a smart city, so they put sensors or 5G antennas into the light poles, and you can easily provide them with DC the same way. And now, because what you are saying, we can use a reliable and safe system, we could also protect it with liquid protection. So you can have a safe and reliable system outside.
So that's it for today. It looks like history is repeating itself with the Battle of the Currents, but now with a different goal. We want to preserve our planet by making better use of our resources. So it's time to act. Thank you.
Thank you.